still be here. Alright, we are going to do, quiet please, reverse chain rule. Chain rule foundation. So I'm going to show you two ways. One is the kind of simplified by lingo, just talking through it. And then one is like the formal process that you would probably be using in college if you took calc in college. How many of you guys plan to take like another calc class in college? How many of you? Yeah. How many of you are going to take the calc class in college by choice? Not like an elective, like you choose me. I don't know. Yeah, that's a fair question. Because you're not going to do it like as an elective. Yeah. All right. So let's review chain rule. So forget the. I'm just using this board as like white space right now. Forget the question. So that's up to you, man. There's no ease or trig in today's assignment. It's just straight up power rule. I'll probably just write these on the back or something. So I'm just reviewing chain rule, but it's not like I collect your notes. So chain rule said we had the big guy and the little guy, right? So we took the outside and the inside. So the outside function of this one is which? 2/3, and then the inside is 3x plus 5, right? So we take the derivative of the outside. So that was bring down the power, reduce by 1. What do we do with the inside? We leave it. And then we multiply by the derivative of the inside, right? So there was this weird thing that no one questions it when I teach chain rule for some reason. I don't know why you would, I guess, but I just like multiplied by the derivative of the inside. I just made this number appear out of nowhere. Everyone's like, oh, okay, cool, whatever. Roll with that. Well, when I integrate this number, I'm going backwards, so I'm going from here to here now. So I'm going to have this number out here. The derivative of the inside is going to be out here. And when I integrate, it's going to disappear. And then everyone freaks out. Like when I made it appear out of nowhere, everyone was like, oh, yeah, that totally makes sense. That's cool. When I make it disappear, you're like, wait, you can't do that. But it's the same thing. It's like the back and forth of it. Yeah. Oh. Thank you. All the stuff I said still makes sense, right? It's just everything. So what you need to have, so in this equation, let's do the integral. Let's do number 1. So in my lingo, I would say the outside function is the square root. The inside function, or let's make it 1/2, like 1/2 power. So let's rewrite this as 30x squared, 2x to the third minus 1 to the 1/2. The inside function is your 2x to the third minus 1. We're back on the number 1 main page. When we do chain rule with derivatives, the derivative of the inside appears. We multiply by it. When we integrate, that has to be there so that it can disappear. So I have y equals cosine of 6x. You tell me, hey, the derivative is negative sine of 6x times 6. This appeared. We created it. We multiplied by it. It came out of nowhere. When I integrate, it's got to be there so that when I go backwards, it disappears. It gets like sucked back into the 6x. So we need to have 3 things in our equation. We got the outside function, the inside function, and then the inside function prime. Like the derivative of the inside needs to be there so that it can get sucked back in and go away. So what's the derivative of our inside function? Wow, we got a few derivatives. Wow. What? 6x squared. Like 6 people. 6x squared. Okay. So this problem we cannot do in its current form. Because this is supposed to be a 6x squared. If it's a 6x squared, I can keep going. I can make it it'll disappear and I can do the problem. But it's not a 6x squared. So I'm going to turn it into a 6x squared. Well, when you can only multiply by numbers. You can't multiply by like x's. So what I'm going to multiply the inside here by 1/5. Well, that means I have to multiply the outside by 5. So my new problem is this. So I didn't really, like that's still 30x squared, right? I just like split it up. So now I have what I'm looking for. So what I want to see is the little guy, the big guy, and the little guy prime. And if you have that, you're good to go. Your job is to, so the 5 is going to hang out here. Your job is to integrate the big guy. The big guy's the power. How do I integrate power? I add 1 and multiply by the reciprocal. I add 1 and I multiply by the reciprocal. What do I do with the little guy? What did I do with the little guy when I took the derivative? I don't bully the little guy, Mr. Packard, right? I leave him alone. And you're done. That's your answer. So you could, like on the AP test, they'll probably write it like this. And you're good. So the derivative of the little guy disappears. It appeared when we took the derivative, like we multiplied by it, and said, hey, multiply by this thing. When we go backwards, it's the opposite. So let's check our work here. If we take the derivative, if this is y, and we take the derivative, if I take the derivative of this, if I did it right, shouldn't I get that? Because derivatives and integrals are opposites. So take the derivative. What's 3 halves? Bring it down. 3 halves times 10 thirds. So those will cancel. You get 5. 2x to the third minus 1 to the 3 halves. But then what would you multiply by? The derivative of the inside, which is not 2. It is 6x squared. Well, what's 5 times 6x squared? 30x squared. Where'd I get what? I add 1 to the power, and then I multiply by the reciprocal of the power. That's the power rule we've done the last couple of days. What's up? Where? Oh, there? No, yeah, you're right. Yeah, thank you. I was so focused on the 5 and 6x squared. Alright, I'm gonna do it again. See if I can make it make more sense in like a shorter way. That's wild. So what I'm looking for, I want to be able to point at, first of all, let's just rewrite it. I'm doing the same problem. No, I'm re-explaining, I'm just doing that same problem, explaining it again. I don't give a crap if you write it down. Can you imagine like raising your hand in a college class and asking the professor if you should write it down? Like that's what you're. It is. Yes. There's not product rule for integrals. And there's not quotient rule for integrals. But there's this like over the top. Okay. So what I want to be able to point at is the big guy, the little guy, and then I'm like, is this the little guy prime? I don't know. If it's not, which it's not in this case, right? Because what's the derivative of the little guy? I'm just re-explaining the same problem, thinking it'll make more sense this way. So that's supposed to be what? 6x squared. It's not. So I'm going to make it that. Then I got to balance that on the outside. And now I can say, yes. Okay, so if you want to rewrite it now, you'll probably get to the point where you're not rewriting it. But now I've got this. That's my big, my little. Now I've got little prime. So you integrate the big guy, leave the little guy alone, and then the derivative of the little guy vanishes. So I integrate the big guy, so I add 1 to the power, multiply by the reciprocal, I leave the little guy alone. This 5 has to come with it. And then what happens to the little guy prime? It's gone. And then don't forget to put your plus C. So you're basically done. So now it's just 10 thirds. Questions I can answer at this moment. Besides, can I actually write this down? No. So my goal was to make this. This was 30x squared. I needed to be the derivative of this. I needed to be 6x squared. Okay. You're going to be able to multiply by a constant to make it happen. Yes. I don't want to say oh. I don't like the word always, but that's like the general. Yeah. So let's look at this one here. So this is my big guy, right? My little. Sometimes, like, I feel like I'm being sexist, saying like big guy, little guy. But then I try to say like big girl and little girl, and that just sounds like really creepy. So I'm not trying to be sexist. It just sounds way more normal if I say big girl. Big it, little it, big day, little day. Okay. This is supposed to be my little guy prime. What is little guy prime supposed to be? Like, what is it? It's 10x. This is 40x. So I don't really want to think about it like taking out a 4. I want to think about it like putting a 1/4 here. So what do I turn this into? 10x, which is what it's supposed to be. And then I'm balancing it out by putting a 4 on the outside. So now I have this. I mean, it might just be like we're phrasing it differently, but taking out a 4 I don't like. Like this still means 40x. I just split it up and put it where I wanted it. If you take out a 4, like I don't know. Okay. I mean, as long as you're getting it right. We might just be saying the same thing different ways. We'll find out. No, if he's doing it right, I don't care. I don't care how he talks about it if he's doing it right. We might just be like phrasing it. So this is my big. This is my little. This is now my little guy prime. So what's going to happen to little guy prime? He goes away. Then I integrate the big guy. The big guy has a power. How do I integrate powers? I add 1, and I multiply by the reciprocal. I do still have that 4 out there. So it's -2. And then what happens to the little guy? The little guy stays. And then if you want to check it, take the derivative. We should check it. Bring down the -2, so we're going to take the derivative. So derivative would be -2 times -2 is 4. Leave the little guy alone. Reduce the power by 1. Multiply by the derivative of the inside. Did we end up with what we started with? We did, because that's 40x, right? Yeah. was weird, wasn't it? Look at that was like a Pegasi question. You really elevated your question. You went from what's your favorite movie to asking Pegasi. Yeah. Yeah, it's a good question. So, what's your favorite color? Now they're exchanging roles. Iggy. It does, but then like you just like four times a constant is still a constant, so you just call it constant. So I cut it with the brackets like here. It doesn't really matter. Why you say negative exponent? Okay. X. There's that. I'm just saying. Like, I don't understand what your point is. Is this a question? Oh, gotcha. No, I don't. Don't worry about it. That's okay. Well, so yeah, check your answer.
That's why you ask questions.
So for three, I'm just gonna keep going. Is that reasonable?
Yes.
Keep going through. So, so I don't want the root there. So I'm gonna go 5x to the third plus 1 to the 1/2 times dx. And then, so what's the big guy? 1/2 power. Little guy? This part. And little guy prime. So what's coming is you got trig and e's and ln's and all that stuff. And so you can see you got to know how to integrate all those things because they might be the big guy. But you also have to know how to take the derivative of all those things because they might be the little guy. So this is why memorizing all those things is like essential. Crucial. Okay, so little guy is 5x to the third. So I'm just gonna like over here and work. Little guy is 5x to the third plus 1. Little guy prime would then be 15x squared. Well, this is not 15x squared. It's 45x squared. So what do I need to multiply by? A third? Because now what is that? What is this piece here right now? 15x squared. I balance it out. And then what's going to happen to this? Once I have little guy prime set up, what can I do? He's gone. I integrate the big guy. So the big guy is a power, so I add 1. I multiply by the reciprocal. There's already a 3 out there, so that has to come down with it. I leave the little guy alone. And then I remember my plus c. And then you would go, okay, like 3 times 2/3 is 2. How are we doing? Yeah? You sound surprised I was able to teach you. Actually, Mr. Davis, you taught me. So, there's the two ways to do this. There's like the college way. I showed you kind of the informal, like college is going to talk about like big guy, little guy prime. I think they're going to give you like a formal process. I'm kind of thinking it'd be better if you did this for a little bit first and then I showed you that. What do you guys think about that? Let's do that. Let's say go to like number, how many are on the first? Go up to like number 10. Do it this way. And then I'll try to show you the other way. And then for the gateway, like I don't care. You can pick whichever